Picture this. You're floating in a metal room the size of a walk-in closet. You've been floating in it for 11 years, and outside the window, there is nothing. No stars, no light, no earth. Just you, just the hum, and 2.9 billion kilometers of nothing between you and the only home you'll ever know. Now here's what's really terrifying. You made it. You actually made it to Uranus, and you're about to find out it doesn't matter, because you will never, ever go home. Hey, quick question before we go any further. Where are you watching this right now? Couch? Bed? Bathroom? Drop it in the comments. I'm genuinely curious. Stick with me until the very end of this video, because the real reason you can never come back is not what you think. It's not the cold. It's not the pressure. It's not even the planet. It's something that happens to you on the way there, and by the time you arrive, it's already too late. That reveal is coming, but first, let's rewind. Most people have no real sense of how far Uranus actually is. So let me put it this way. Mars, the planet we've been dreaming about colonizing for decades, sits roughly 55 million kilometers away at its closest. Uranus? 2.6 billion kilometers. That's not twice as far. That's not 10 times as far. That's nearly 50 times farther than Mars. If you drove a car, non-stop, no sleep, no gas, at highway speed, it would take you over 3,000 years to get there. And the fastest spacecraft we've ever built would still take somewhere between 12 and 15 years to carry a crewed mission. Let that sit. Not 12 to 15 months, years. A child born the day your ship launches will be a teenager by the time you reach Uranus. Now, here's where it gets complicated. Voyager 2, the only probe in history to ever visit Uranus, launched in 1977 and arrived in 1986. That's 8.5 years. But Voyager 2 was tiny. No life support, no water, no food, no humans. A crewed mission is a completely different animal. You need oxygen recycling systems, water filtration, medical equipment, enough food to keep people alive for over a decade, backup systems for the backup systems. All that mass means slower thrust, and slower thrust means more time. 12 to 15 years, one way. Think about what 15 years inside a metal box actually means. In 15 years, fashions change completely. Entire technologies are born and die. Friends get married, parents get old. Cities you knew look different. And you're in a room with the same 4 people, the same recycled air, the same hum, day 1 through day 5,475. Studies on Earth-based isolation, even with emergency exits available, show that even the most psychologically resilient people start to fracture after a few years. On this mission, there is no door to open. There is no, "I need some air." At Uranus's distance, a message to Earth takes 2.5 hours just to arrive. A round-trip conversation with mission control, your lifeline, your anchor to home, takes 5 hours minimum. You are, for all practical purposes, completely alone. But isolation is just one of the forces working against you. The most dangerous one, you can't see it, you can't feel it, you can't smell it. It's radiation. On Earth, our atmosphere and magnetic field absorb almost all of the cosmic rays and solar particles that the universe constantly fires at us. Astronauts on the International Space Station receive around 150 millisieverts of radiation per year, already 50 times what we absorb on the ground, and they're still partially protected by Earth's magnetosphere. Out in deep space, heading to Uranus, there is no shield. NASA's career limit for astronaut radiation exposure corresponds to roughly a 3% increase in fatal cancer risk. A round trip to Mars alone, just 2 to 3 years total, would push close to that limit. A mission to Uranus and back? 25 to 30 years total. The radiation dose wouldn't just exceed the limit, it would obliterate it. And here's the part I need you to hold on to, because this is where it all starts coming together. Radiation damage is cumulative. Every charged particle that tears through your DNA adds to a total your body cannot repair fast enough. You can't undo it. You can't flush it out. It follows you. While the radiation is quietly shredding your cells, something else is happening to your skeleton. On Earth, gravity constantly pulls on your bones. That stress, that load, is the signal your body uses to keep bone density up. Take gravity away, the signal disappears. Your body stops maintaining bone mass. Astronauts on the International Space Station lose about 1 to 2% of their bone density every single month. After 6 months, they come home and need weeks just to walk normally again. Now stretch that out. After 5 years of weightlessness, your skeleton begins to resemble that of an 80-year-old with severe osteoporosis. After 10 years, the bones that once held you upright become so porous, so fragile, that stepping onto a planet with real gravity might literally shatter them. Astronauts on the ISS exercise for 2 hours every single day on specialized resistance equipment, and they still lose bone. On a spacecraft to Uranus, no amount of exercise would be enough to fight a decade plus of zero gravity. Your muscles follow the same fate. Without gravity to work against, they atrophy. Legs, back, core. Everything you use to stand and move begins to waste away. Your heart, which is also a muscle, starts to shrink. It no longer needs to pump blood upward against gravitational pull, so it doesn't. Studies show the heart can lose up to 20% of its mass during extended space missions. Blood volume drops. The entire cardiovascular system restructures itself for a world without weight. When astronauts return to Earth after just 6 months, many of them faint trying to stand up. Their hearts can't push blood to the brain fast enough. After 12 to 15 years, the heart wouldn't struggle. It would be incapable. It would have become the heart of a different world, reshaped for weightlessness, completely unfit for the planet that built it. And then there's the brain. Radiation exposure over a decade doesn't just increase cancer risk, it causes measurable cognitive decline, slowed reaction times, memory problems, difficulty making decisions. The kind of damage that astronauts returning from much shorter missions have already shown signs of on brain scans. Now stack isolation on top of that. Depression, anxiety, sleep disorders, interpersonal conflict within a crew of 4 people who haven't had personal space in over a decade. These aren't hypothetical concerns, these are near certainties. By the time you arrive at Uranus, after 12 to 15 years, you are not the same person who left. Not physically, not mentally, not neurologically. And this is the part I told you about at the start of the video, the reveal I promised you. The reason you can never come back isn't just that the return trip would take another 12 to 15 years. It's that your body has already become something else. It has adapted, involuntarily, irreversibly, to the conditions of deep space. The gravity of Earth? Your heart can no longer handle it. The weight of your own skeleton? Your bones can no longer support it. You have, slowly, over a decade and a half, ceased to be an Earthling. And here's the most brutal irony of all. After 15 years, after everything your body has sacrificed to get there, Uranus isn't even a destination. It has no surface. It's an ice giant, which means beneath its swirling clouds there is no ground, no rock, no place to land. Just a churning ocean of superheated water, methane, and ammonia compressed to pressures that would crush any structure we've ever built. NASA has stated plainly, the extreme pressures and temperatures would destroy a metal spacecraft. Descending into that atmosphere wouldn't be landing, it would be disintegrating. Even hovering in the upper atmosphere is a nightmare. Uranus holds the record for the coldest planetary atmosphere in the solar system, colder than Neptune, which orbits 1 billion kilometers farther from the Sun. Cloud-top temperatures hit minus 224 degrees Celsius. Exposed skin freezes solid in seconds. The atmosphere is 83% hydrogen, 15% helium, and a 2% cocktail of methane, ammonia, and hydrogen sulfide. Hydrogen sulfide is the chemical responsible for the smell of rotten eggs. If you could somehow survive long enough to breathe, the stench would be the last thing you'd notice before the lack of oxygen finished the job. And the wind. Uranus may look calm and featureless in photographs. That's a lie. Wind speeds can reach 900 kilometers per hour. The most powerful hurricanes on Earth top out around 300. Those flatten cities. Then there's something about Uranus that makes it unlike anything else in our solar system. It's tilted almost completely on its side. Not Earth's modest 23-degree lean, 98 degrees. It rolls around the sun like a ball rolling across a table. This creates the most extreme seasons in the solar system. Each Uranian year lasts 84 Earth years. For nearly a quarter of that time, one pole faces the sun directly. If you were standing at the North Pole, you would experience 42 years of continuous sunlight, no sunset, no night. Then the orbit shifts, the sun disappears over the horizon for the last time, and doesn't rise again for another 42 years.
So, let's say, impossibly, that you survived it all. The journey, the radiation, the isolation, the body breakdown. You orbit Uranus, you study it, you do your job, and then you point the ship home. Another 12 to 15 years. 25 to 30 years total in space. By the time Earth comes back into view in that small window, a pale blue dot growing slowly brighter, your bones would be hollow, your heart too weak to pump against gravity, your muscles gone, your brain scarred. Stepping off that ship onto solid ground might literally kill you. Not metaphorically, literally. The Earth's gravity, the very force that once held you up, would now be working against a body that was no longer designed for it. We've sent exactly one spacecraft to Uranus, Voyager 2, January 1986. It collected most of its data in 6 hours before continuing on into the outer solar system. That's all we have. 6 hours. And in 2022, the Planetary Science Decadal Survey declared a Uranus orbiter the top scientific priority for the coming decade. That mission, if it happens, will be robotic, because we've learned enough about what space does to the human body to understand where the line is. Mars sits on the very edge of what we might attempt. Jupiter pushes well past it. Uranus isn't just beyond the line, it's in a different category entirely. We are products of this planet. Every bone, every heartbeat, every breath is tuned to Earth's gravity, its atmosphere, its radiation environment. Take us away from that long enough, and the tuning breaks. The instrument can no longer play the same music. Uranus will sit out there in the cold and dark, rolling sideways through space, wrapped in methane and mystery, and it will keep its secrets a little longer. Not because we can't reach it, but because reaching it with human hands would cost us the very thing that makes those hands worth sending. If this video messed with your head a little, good. That was the point. Drop a comment telling me, would you go knowing you could never come back? And if you want to go deeper on what space actually does to the human body, there's a video right here that continues exactly where this one left off. I'll see you in the next one.